Hello, Psychology of Learning students. So this is the third video of the third chapter in week 3. Yay! So this is a short video where we're going to talk about the different theories of classical conditioning, and we're going to cover extinction. So let's look at the PowerPoint slides for this chapter, for chapter 3. These slides were made by Dr. Stephanie Stern. She did such a good job on them. So in the first video, I had you do a practice activity. So remember that activity, I asked you to come up with an intervention to reduce the behavior, a behavior that you wanted to get rid of in either a friend or a significant other or a child or something. And we're going to use that activity when we get to the next chapter, chapter 4. But I bet as you're watching these videos, you're sort of fine-tuning and honing your interventions because you're learning more about what interventions will be more effective than others. So in the last video, when we talked about higher order conditioning, and especially the different factors that affect classical conditioning, I wonder if some of your interventions were modified. Now that you know that delay conditioning is much better than simultaneous conditioning, then you're probably going to make more of, you're probably going to utilize delay conditioning if you had simultaneous conditioning in your initial intervention strategy. I bet you started, modified your intervention, so now the CS and the US are probably more intense, and maybe try to find CSs and USs that more in an evolutionary perspective are more likely to be paired together, since you know that all of those will make the classical conditioning work better. So, okay, in this video, we're going to talk about extinction and the theories of conditioning. So let's get started. What is extinction? Extinction is will occur if the CS is presented over and over without the US. So if we present the metronome but no food, and of course the dog is going to salivate the first few times, right? Because you've already taught the dog metronome. Well, you did. Let's go back to the very beginning. Metronome, food, the dog salivated. Metronome, food, the dog salivated. Metronome, food, the dog salivates. So now metronome and the dog will salivate. But every once in a while, you need to pair those two things again together, the food with the metronome. Otherwise, extinction will occur. So if you just go on and on and on with metronome, no food, yes, they're going to salivate. Metronome, no food, yes, they're going to salivate. Metronome, no food, yes, they're going to salivate. But over time, metronome, no food, metronome, no food, metronome, no food, metronome, no food, the dog is going to learn that the metronome no longer is paired with the food, and the dog is going to stop salivating to the metronome. When that happens, we say extinction has occurred. So learning occurs when the dog starts to salivate to the metronome without the food being there. Extinction occurs after the metronome has been presented so many times without the food that now the metronome alone no longer leads to the salivation, to the salivating. So extinction occurs after you present the CS, the metronome, without the US, the food, over and over and over. Extinction is different than forgetting. So sometimes students will get this confused. So forgetting is when you stop doing something because it's like the trace or whatever you're thinking becomes weaker and weaker and weaker. Extinction is not that the salivation becomes weaker. It's learning. It's almost like new learning that the food, that the metronome is unlikely to be paired with the food, so salivation doesn't happen anymore. So it's not that you've forgotten or that the dog has forgotten that the metronome leads to food. It's that the dog has now learned something new, that the metronome is not going to be paired with the food, so the salivating goes away. So it's more of a contingency issue. It's like new learning, not unlearning or forgetting. Okay? The weird thing or fascinating thing about extinction is after extinction has occurred. So first, we taught the dog to salivate to the metronome. Then we presented the metronome without the food a whole bunch of times. So now the metronome alone doesn't lead to salivation at all. But sometimes if you wait a little bit and you present that metronome again, that dog will salivate, even after extinction has happened. When that happens, we call it spontaneous recovery. And it's a fairly common practice. So spontaneous recovery is after extinction when the presentation of the CS leads to the CR. So most of the time after extinction, you do the CS, you don't get the CR. That means extinction has happened. But every once in a while, we'll have that spontaneous recovery. Right? So the next thing that I want to talk about are the theories of conditioning. And your book goes through several of them, and I'm only going to go through the ones that the book goes through. So one of them is called the stimulus substitution theory. And this was the theory that Pavlov created. And so Pavlov believed that there were physiological mechanisms that involved in these reflexes. So it's because of the neural connections, or the way our nerves are connected, that the US will stimulate the nerve fibers that creates the UR. So there's a neural link there, either through our neurons talking or our nerves, but there's a link there. He believed that the CS becomes a substitute for the US, that on a neurological level or on a physiological level, the metronome starts to do exactly what the food used to do in the dog. Okay, so it doesn't involve like a new network, it's the CS substituting for the US and it leads to the new response. Now, the problem with this is if that really were the case, then the CR and the UR should be the same. They should be the same level of intensity, equally reliable at the same time. But there's so many demonstrations now where the CR is weaker, less reliable, and more slowly appears than the unconditioned response, which leads people to think that you might be onto something here, Pavlov, but we don't know that that's the whole story. Another theorist, Kimball, in 1967, came up with preparatory response theory. And he believes that the unconditioned response is innate and designed to deal specifically with the unconditioned stimulus. The CR just is there to prepare our body to accept the UR. He doesn't think that the CS like becomes the US neurologically and therefore leads to the UR. Instead, he believes that the CR prepares our body, that the UR should be coming, that the US is going to happen, and so that you got to get ready for the UR. And I like the example that it uses in your book. It says like, if a rat is in a field and a predator comes, let's say a mouse comes, the rat is, by seeing the mouse, when the mouse sees the cat, the best thing that that mouse could do to live longer is to freeze, like to not make any movement, to jump out of its way. But if the mouse just sees the cat, like the cat's not actually right on the mouse, jumping is just going to make it less likely for them to survive. So it would be better to freeze in that situation. So the conditioned response of freezing is a much better response to the sight of the cat, or that would be like the CS, where the cat being right on them or very close to them or touching them, that being the US, would lead to a better UR of jumping out of the way. And so Kimball does not believe that the UR and the CR are always the same. In fact, he believes that the CR just prepares our body for the UR. In this case, the freezing is a better thing to do than hopping out of the way or trying to pounce out of the way. Another theory is compensatory response theory. And this says that the CR prepares the animal for the US, but by compensating for its effects in the reversed way. So most of the accounts that use this talk about drug use intolerance, and we'll talk about more when we get to the next chapter, chapter 4. But this is like the CS lets the body know, this US is coming. So we better compensate because we know this US and UR are on its way. And so the CR actually prepares the animal for the US. And With drug tolerance, we mean you're going to need more of the drug to get the same response, because your body's compensating with the response that they expect the drug to do, because your body doesn't want this drug to have too much of an effect. Okay. Now, the theory that is, oh, there's one more, sorry, conditional awareness. This is the idea that the conditioned response is the result of an awareness that we've been conditioned. So the dog knew that the bell meant food was coming. So, and because the dog's aware that the bell means that food is coming, then the dog starts to salivate. But there's an awareness in there, not just a predictive value, but actual awareness. The problem is that conditioning happens oftentimes without people even being aware of it. And it also can happen in animals that don't have any kind of awareness. I think your book talks about how that has even occurred in amoebas. So, you know, it's not going to be, it's unlikely to say that it played a role there. Okay, the last theory that I'm going to talk about, and this is by far the most influential theory in the last 40 years, is the Rescorla-Wagner model. And with this model, okay, so when I taught this class last, it was about 10 or 11 years ago. And I actually had students use the formula, and I had exercises where we would change some of the numbers in the formula and show what the formula would predict given those different numbers. And then we talked about studies that showed that that is indeed what they found, even findings that you wouldn't expect that were counterintuitive. I think in the last 10 years, I have seen such a push away from this. So if you look at the programs, psychology of learning that's taught in the state, the classes are not having students do that anymore. In the last 10 years, that practice of having students do that has gone away. And I think it's gone away in part because we want to have more time in the course for talking about how classical conditioning can be applied to your life and to the lives of those around you, so that you can make your life more beneficial. And that seems to be a more important way to use this information than to show that you can work with these formulas really well. And so I'm going to take it out of this course too. There will be nothing in here. You won't be asked to use the formula in any way. I'm just going to go over it with you. Okay. So the Rescorla-Wagner model says that there's basically a limit to how much conditioning that can occur between a specific US and CS. And it depends upon the specific US and CS. So some US and CSs can bond together better and more easily than others. And we talked about that, like especially those that have an evolutionary advantage are going to be easier to happen. The other thing that the model says is that each pairing leads to less learning. So the first time that they're paired together, we get lots of learning. Then the next time there's a little bit less learning. They're still learning, but a little bit less. The next pairing, a little bit less. And after you've had a whole bunch of pairings, then each successive trial is only letting you change just a little bit. And the formula that we're used here, of course, is a change of V on any trial N is equal to a constant times lambda minus V on the last trial, N minus 1. So let's really walk this through. So the triangle or delta just means the change. So we're looking at the change of learning in any given trial. That's what the whole formula is. How much is learned in this one trial? That's the change of V in trial N. V is the value of the strength between the US and the CS-US association. N, of course, is going to be the trial, whichever trial you're on, 1, 2, 3, 4, 500. C is a constant, always a number between 0 and 1. And we sort of guess at it. If you've got data from an animal, you can guess at it, but usually it's used more to say, what would happen if we did this? What would happen if we did that? And then lambda is the total amount of learning that can occur. It's always going to be a number equal to or greater than 0, because you can't have negative learning. So if you want to predict the amount of learning on a given trial, you subtract the amount of learning that has occurred from the maximum amount of learning that can occur, and then you multiply that number by a constant representing the conditionability of the stimuli paired. And that is what the Rescorla-Wagner model is saying. I love how your book, so please go through this with your book. Your book will talk about what would happen if you change some of the variables. And it lets you see what happens over time. So it lets you really see how much learning takes place on each trial if you keep like the constant the same, and what happens if you change lambda or change the constant. So please go through those formulas, knowing that you won't have to go through them on the exam or anything, but just so that you get a better understanding of the Rescorla-Wagner model. Okay, so we have now covered everything in chapter 3 that I'm going to cover. I think it's important for you to do the practice quiz that's on page 93 and 94 in your text. I think that will help you to prepare for the exam. The exam, remember, Unit 1 exam is going to cover chapters 1, 2, 3, and 4. So we're 75% done now, one more chapter to go before the exam. If you have any questions about any of this material, please contact me at maryd@cameron.edu. All right, I hope you're finding these videos helpful. Thank you.